Hey everyone, Zach here, and welcome to Lesson 6 of this series, an introduction to AI in Unreal Engine. In this video, we'll be going over how to switch between our finite states. Sorry about the delay in getting this video out. While it's been recorded, things have been a bit hectic between moving houses, changing jobs, waiting for my internet to get properly installed, and some other stuff like losing a drive. This video and this series have been brought to you by my Patreon sponsors like Nemian Games. If you want to have a voice in what topics I cover on this channel, consider becoming a Patreon sponsor. That said, open up your project and let's get started. Hey everyone, welcome back to the editor. And in the previous video, we made our 3 states for our finite state machine. We then created a switch and a way to test that all 3 states are working. Now in this video, we are going to handle how we transition from our patrol state, or our find target states, into our chase or retreat state. And the way we're going to do this, and there are much more complex and interesting and realistic ways to do this. In fact, I've done one in the RTS tutorial series, is we are going to base it on fear level. We're going to say there's a 20% chance that the enemy unit becomes afraid of our friendly unit, and they decide to run away. Now again, there are more interesting ways using behavior trees to do this, and if you're interested in that, take a look at my RTS tutorial section where we do our behavior tree. You can adapt that content to work here. So what we're going to do is we're going to go down below our event tick here, and we're going to create a new event. So this will be a custom event that I'll name transition check. So this will check what state we should transition into when we complete our base state. And we'll handle transitioning back to our base state in the branch for chase and retreat. We already kind of handle it here for going from chase back to find target. So the way this is going to work is we are going to use a random number. Now there are 2 ways to get random numbers. We've been getting it this way for the most part. However, this offers a uniform or flat distribution of random numbers. You're as likely to get 0.05 as you are to get 0.6, 0.7, all the way up to 2. It's a flat distribution. Technically, it should be a normalized distribution, so it might be a bell curve, depending on how you've set it up and depending on how you do this. However, one way to get a properly, truly random effect each time, and thus something that is a little bit more realistic and a little bit less controllable, is to use a random from stream. So what we're going to do is we're going to search for random float in range from stream. And you have the stream node down here. And this requires a seed. And a seed will just randomly pick a set of various numbers and distributions to use. Now, if you use the same seed over and over again, you are going to have the same effect over and over again. But you can change the seed to get more breadth from this. So what we're going to do is pull back from our stream here, and we are going to make a random stream. Now, our initial seed we can set here, but I don't want to use just a preset one. Instead, what I'm going to do is I'm going to pull back on this one, and I'm going to get random integer. And the random integer I'm going to pick for my max will be 32,767. Now, as I said, we want to say there's a 20% chance that the target will be, the unit will be afraid, the enemy unit will be afraid of our target. Now, the way that's going to work is we can't set this, from 0 to 1, because we're only getting one return value. And we want to get the most mileage out of this return value without having to do any extra bits. So because we have one value, I'm going to use this as the center point and go 10 above this number and 10 below this number are our range of 20%. So the way that works, the way you're going to do that is you set the min to 0.1, so that's 10%. It's a proportion of 10. And the max to 0.9. So a proportion of 0.9 is 90%. That way, if the critical value is 0.9 on the dot, then the upper limit is 100 and the lower limit is 0.8. If it's 1 or 0.1, then the lower limit is 0 and the upper limit is 2. And I'm going to name this my critical value. And I'm going to set my critical value each time I call this transition check so that this number changes every time it's called up. And then I'm going to get another random number. This will be our score. So we want this number to fall inside of our critical range at 20% if they're afraid in order to retreat or run away. So I'm just going to pull off of this, and I'm going to name this one score. Plug that into there. And in this case, well, our score can either be 0 up to 1. Not either or, sorry. It can be min 0 up to a total of 1. That one has to have the full range. Next, we need to check, is this value within that 20% range set by our critical value? And the way we're going to do that is we're going to create a branch. I pulled out way too far there. That's fine. We'll leave it for now. So we're going to get our score. We're going to get our critical value. And we want to see, is our score greater than the minimum of our critical values range? So we can't just plug this critical value into here. Instead, what we have to do is we have to minus 10% from our critical value. So that 0.1. And plug that into our less than. So are we scoring greater than our critical range? Now that leaves a lot of numbers available. There's way more. And we have that idea that we only want 20%. So we also need to see, is our score, and I'm going to cross nodes here. I apologize for that. I tried to avoid that. Is our score also less than the max range that we want? And again, we can't just plug our critical value in there. You could if you want to make it a 10% range where it's 10% below the critical value. But instead, what we're going to do is we're going to pull off of here, and we are going to add 10%. So 0.1. That will give us that 20% range for our check. If we are between these two values, then we want to retreat. So we'll put our AND in, plug this AND into our branch here. There we go. And let's just move this a bit closer. And the next thing we're going to do is we are going to set our AI state based on what's returned here. So if we're in that 20% range, we want to retreat. If we're in the rest of the 80% that's remaining, well, we're going to chase that unit. So that is one way you can handle transitions. You could also do it based on the amount of damage a unit's taken. You can add these things together and do damage and fear. The more damage the unit takes, the more afraid it gets. Again, check out my RTS tutorial series for an example of how to do that. So let's just test this out, see how this works. I'm going to put a breakpoint on this transition check. And I said ooh because I realized we skipped something very important. Also compile so we can get the proper breakpoint. We need to actually call this transition check up. And the way we're going to call it up is by going to our find target branch here and breaking the set AI. We no longer want that. And instead, we want to do our transition check. All right, with our transition check in place, we should now be able to test this out. So all we're going to do is hit play, wait for that breakpoint to be triggered, which right there. Control F1 to get my mouse back. I'm just going to move this into another window, and I'm going to step through. This will be 0 for the first time, but once we step past it one step, we can see what the value we got was. It was 0.14, so my critical range will be from 0.4 to 0.24. We have a score. Again, that's going to be 0 the first time, so let's go back, see what it was. And it was, actually, we're going to get the false, because we're above 0.4, but less than 0.24. If we go in here, we'll see that this number is 0.04, and this one is 0.24. And we know that our score, 0.5, meets this and this condition. So we will see retreat. I probably should hit resume. There we go. So if I bring this back over, we see the units running away. Now, you'll actually notice something, we'll talk about this later on, is that if a unit comes up here, it won't ever, even if you have the friendly unit, and you can see it's raycasting forward, jump down from here. And that's to do with the navigation setup. We actually need to tell it that it can jump from that location safely. So we do have a working transition check. Let's test it again, and let's see if we get a false. And we should get a false, 4 out of 5 times. So again, take one step forward. Our critical range is going to be 28 to 48. And our score is under 28. So we'll get a false. And thus we will get a chase. And there we go. We have the chase. And let's see if we can block that unit a bit so he can't keep following him. And thus he'll have to return home. Oh, well, it would help if the friendly unit didn't go that direction right then. Alright, let's try that again, see if we can block him. There he is, he's returning home. And he's going to wait for that unit to come back around. So when the unit comes back around on this side, if you want to keep testing this out yourself, you'll see that he'll transition back into that transition check. And will either decide to run or chase. So that is our setup. Now we could actually make this a bit more clean, and we could instead have this do only once so that it stays through and only ever does it for that one check, and then reset it after a sufficient amount of time has passed using timers. However, I'm not keen on doing that for this because we have other things that we need to explore to make this work even better. So, we need a bit of room, so I'm going to take this transition check, and I'm just going to move it further down. Next, what I'm going to do is, we need to consider, we don't want this unit to run away forever. Eventually, and again, thinking about Skyrim, even when a unit's afraid, and it's begging for mercy, it will return to its normal position. So we're just going to move some things around to give me a bit of room to play with. And we'll even maybe add in a proper wander and find target bit here, so the unit is actually kind of trying to find the target instead of standing there waiting for it to be nearby. What we are going to do is we are going to, now, again, move some of this stuff around because we need a bit of room to play with that final branch. Just do it this way. There we go. Just going to move that there for now. And we'll clean that up a bit further in a moment. We're going to leave this delay in. We are going to have the retreat. Then, we are going to have another delay. So I'm just going to duplicate this over. And this delay will go between 4 seconds and 10 seconds. And then we are going to have a return to default state here. But instead of just repeating this over and over again, we're actually going to collapse this down to a function in a moment, and then we'll return home. So let's do our default state return. Let's grab these two nodes. Let's collapse them down to a function, and this will be returned to default state. Let's go into there for a second. Open it up and put a return node in. Not return home. Actually, we could do the return home there, and it would work perfectly fine, because that's what we wanted to do when it returns to its default state. But I'm going to leave it as 2 separate nodes for now. So we're going to have our return to default state here, and our return home right after. All right, let's just tighten this up a tiny bit. There we go. So now when our unit has had a sufficient time to relax and calm down and stop panicking its head off, or a pawn that is, not unit, sorry, it will return to its default state of finding the target and return home. So now we can transition from our find target to our chase, from our chase to our find target, and from our find target to our retreat, and from our retreat back to our find target. That was actually really confusing to say. We do not have a transition yet between our states here. Now, what we could do is say we could even create another check in here that says if the target stays too close for too long, then it automatically become afraid and go into retreat, and thus make this a properly closed finite state machine. It doesn't need to be fully closed to be a finite state machine. We have a finite number of states. Our AI is picking between the states based on our settings here and based on things happening within each of the individual branches. Now, if you test this at this point, you will run into an issue, especially on the retreat branch. And let's actually test that out. So what we're going to do is we're just going to break that for a moment. And I'm going to plug this into retreat just so you can see what that issue is. So our unit comes up. There we go. Let's wait a tiny bit. We need to wait for it to return home as it runs around panicked. In fact, you notice it's only running in a contained area. That is something we'll have to address as well. There he is. He returns home. Let's close that out. We have an error. Now, if you remembered what I said in the last video, you'll know why that error has occurred. You might not know how to resolve it, but you should know why that error has occurred. We have a delay here. That then sets this. We then have this delay, and this gets reactivated every time this goes off. But it doesn't add to the time. It doesn't reset it. It keeps waiting for the initial count to go through. So, at best, this will fire twice, max of 2 seconds, before this fires once, max of 1 second. Meaning that the second time that fires, we clear this, it's still moving, it's still trying to find that enemy target to retreat from, and thus this is going to return that error. So the way we're going to address that is we're going to break this, drag these out, and we are going to add in a do once node. So do once literally sounds like what it does what it sounds like. It does something once. So do once. We're going to start open, so leave that as false. And then we are going to reset this because we might need to reset this. And we'll do a custom event. And this custom event, we'll just name it restart retreat. And we need to call this somewhere. So where can we call this? Well, oddly enough, and very easily for us, we can call it at the end of our retreat branch here. So after it's returned home, all right, let's restart our retreat. If it gets triggered again right away, fair enough. So now we've done that, we're ready to go again. So that sets up our finite state machine so it doesn't have any issues and that it transitions. You can see it's fairly complex. We had to collapse a lot of things down to functions, and this is rather simplistic, but again, you could do so much more with it. So the limitations are only how much effort and energy you want to put into it. But as I mentioned, this can get really messy, especially when you have more states, more conditions per state. If you need to run multiple things at the same time, so if multiple branches can be going at the same time. So for example, in my RTS tutorial, we have one of it needs to move to a building and stay in that building whilst doing something in that building. We have to run things in parallel, or we have to stop trying to be in the building and just remove the unit from the map and pretend like it's there in the building and have it run the other function or other tasks, since the behavior tree. So this is a bit more limiting. You have to do a lot more work to set this up. But this is a finite state machine. Now, I said we were going to do one more thing, and let's do that one more thing. What we are going to do is we are going to have our unit patrol. So the way we're going to patrol is, well, we're going to be lazy about this. We're going to go over to our friendly unit here, and we are going to take all of this. Let's Control-C copy it. Go to our enemy controller, paste it in there, and I'm going to break that for a moment. plug that into there, plug the move to location into there, and now I'm going to take all of this, collapse it down to a function, and we'll just name this random patrol. Also, I want to resolve the issue on the retreat that I'm being bothered by, and I am going to use the alternative method. I have found that he does run a bit better with this one, or the pawn runs a bit more realistically with it at least. All right, there we go. So, let's then test this out. Also, let's make sure that before we test it out, I think we've already done this. Yep, we set that back to our transition check. Let's hit play. He's afraid and running away. Well, he's running to the same locations as before. And now he's resuming his random patrol. Now, there's a slight issue there. Let's fix that slight issue. Let's go into our random patrol. You can see that raycast was weird, right? So, what was going on with our raycast is we didn't set our start location. Our start location is just this. Let's plug that in, and now put a return node into here. Go back to the main window. And the other issue, if you didn't catch it, is we have no delay in there. So, we're going to have a bit of issues. You can't put a delay into a function anyway, so we're going to put our delay here. And our delay will have a random float in range. And we're just going to copy over our standard one here. There we go. And now let's test it out one more time. You can see that they're both casting. They're both moving forward. The other one's caught up. He's now chasing him. And there we go. The chase is on. Why they're both standing there. There we go. And somehow he's lost sight of him as returned back to his patrol. But don't worry, he'll be passing by soon. There we go, we're on the chase again. And our finite state machine is up and running. Do want to check one thing. That's why he was just standing there. Now, that should actually clear that up. I'm sorry I missed that. So, as you can see, debugging a finite state machine, even right now, we've had a couple of issues, can take a fair amount of time to find where those issues are. I mean, we ran a couple of tests and we saw that it was working. We saw there were some problems. But we were able to fix it because we tested everything one step at a time to see where the problems were. So this takes us through our finite state machine. We'll begin talking about navigation in the next video. We might consider what we can do with our inability of our units to jump here. And then we will consider what we can do to make our units move in other ways with regards to navigation, how they can navigate better. We'll talk a little bit about flocking mechanics potentially. And then we'll be moving on to more advanced topics in our AI setup. All of that said, this topic was brought to you by my Patreon supporters who voted on having AI systems as a video series. If you want to help support this channel, consider becoming a supporter on Patreon. Also, you get access to the files, depending on which tier you're at, and you get a chance to vote on future content that will be covered on this channel. If you want to be there for when the next tutorial comes out on navigation and AI control, make sure to hit that subscribe and notify icon so you know when that video is out. I look forward to seeing you in the next tutorial, and I hope that you have a wonderful day.